So work is what you get paid for, eh? So if someone wants a hole dug, they give you money to do work, and the work you have to do is digging the hole. And that's how the economy works, and it's also how physics works, right? Because work in physics means energy. Work is energy changing from one form to another. So if you have to dig a hole, the first thing you do is get out of the bed and have your Weet-Bix, and that's like chemical energy going into your body, whatever you have for breakfast, eggs or bacon or whatever, and then you go to work and you dig the hole. And so to dig the hole, you get the spade, poke it into the ground, and you lift the dirt up. What sort of energy are you giving to the dirt?
Gravitational.
You're giving it gravitational energy. Where's that energy come from? You can't create energy. Where's it come from? Muscles. Where did your muscles get the energy from? The Weet-Bix, right? And so then you throw the dirt over your shoulder. What sort of energy are you giving it?
Kinetic.
Giving it kinetic from the muscles, which comes from the Weet-Bix. And so the Weet-Bix is called chemical potential energy, and even when that goes into your body just processes that chemical potential energy a bit more to make it readily able to be used. Then we change chemical potential energy into gravitational potential, and what we notice had to happen to make the energy change. There had to be a force, like to change that chemical potential in your muscles into gravitational, to lift up that dirt. You had to push upwards, you had to push that dirt up to get it up high. And then when you throw it over your shoulder, you've got to push the spade to make the dirt accelerate over your shoulder. And so the thing we're seeing happening is that for energy to change from one form to another, we have to have a push, we have to have a force acting. So a force is what changes energy from one form to another. Work is just energy. Work is the amount of energy that's been transformed from one form to another. Because work's just energy, what's work measured in? Joules. The reason that work is a useful concept for us is it helps us link forces to energy. It helps us understand that what forces do, what pushes do, is they change energy from one form to another. We've got an equation. Check it out. This is where it gets confusing because we use capital W sometimes to mean weight. We also use capital W to mean work. F means
Fungus.
fungus. D means distance over which the force acts. And you'll notice I chose to use the dot, not the X, as my multiplication sign. What does the dot mean? Well, these have a whole lot of meaning now that we're playing with vectors and not just numbers. Vectors meaning things that have a direction and a size. So force, you can't push something if you're not pushing it in a direction, and you can't have a distance that's not in a direction. These are both vectors. The dot means that they have to be in the same direction. It means multiplying the force and the distance that are in the same direction. And so, if I have the 1 kilogram hole punch and I lift it up, 1 kilogram hole punch, how much is the weight?
1 kilogram.
How much is the mass? 1 kilogram, how much is the weight?
2 kilograms.
The mass is 1 kilogram, how much is the weight?
1 kilogram.
What's weight measured in? Newtons. How much is the weight? 10, right? Because mass times gravity, 1 times 10. 10. So the weight force, what way's the weight force on the hole punch?
Down.
Downwards. So if I want to lift the hole punch up 1 metre, how much work have I done?
1
How much was the force?
1 10.
10. How much was the distance?
One.
One. Those are in the same direction, so I did
10.
10 joules of work. Then, if I let the hole punch go and it goes down 1 metre, how much work did the hole punch do?
10
And
10.
joules.
Now the hole punch goes 1 metre to the right. How much work?
Oh, it's isn't that like 50?
What direction is the weight in?
Right.
What direction is the weight? Weight's always down, gravity's always down, weight's always down. What direction did it move?
Right.
Can we use that equation to work out how much work was done?
No.
It's more complicated, because I definitely had to do some work to accelerate it, and then I had to do some more work to decelerate it, but those forces are not linked to the weight, they're not linked to gravity, and so if the hole punch is just sitting here, it's got force. Is it moving?
No.
So no work's being done, no energy's being transformed. However, when you let it fall,
Broke it.
then the gravity does work on the hole punch and changes that gravitational potential energy into kinetic energy. That means work is being done because the force and the distance were in the same direction. See how that dot's really important? It works if they're in the same direction, not if they're in different directions.
Right.
Okay.